Well, we've given a few minutes for folks to join. I can see we're up to about 22. We'll get started and welcome everyone to SRIA's spotlight on the ENMAX project. What I'd like to do is first, in an important act of reconciliation and gratitude, I want to take this moment to acknowledge that SRIA operates across Alberta, which is comprised of Treaty 6, Treaty 7, and Treaty 8 territory, the traditional homeland of Métis and Inuit, and ancestral territory of many First Nations, including the Cree, Dene, Saulteaux, and Nakota Sioux. And from the Calgary area where this project is taking place, the Blackfoot Confederacy, comprised of the Siksika, the Piikani, the Kainai First Nations, the Stoney Nakoda, including Chiniki, Bearspaw, and Wesley First Nations, and the Tsuut'ina First Nation. And we recognize that the city of Calgary is home to Region 3 of the Métis Nation of Alberta. We acknowledge that many First Nations, Métis, and Inuit who have lived on and cared for these lands since time immemorial. So good afternoon, everyone. I'm Alex Joseph, the Program Manager of the Smart, Sustainable, Resilient Infrastructure Association, otherwise known as SRIA. SRIA is a not-for-profit organization that's taking a collaborative, industry-led approach to reducing carbon in the built environment by accelerating the adoption of innovative low-carbon solutions. We're currently funding about 20 demonstration projects, of which the ENMAX project is one, and also 3 future skills projects across Alberta. And we're actively sharing the results of those projects through webinars like this one we're presenting today, and through the Building Innovation Reference Center, which is a searchable online database of information related to those projects, from planning, design documents, energy models, to final results. Just 2 upcoming events that folks may be interested in. One is in our business growth, we're having a lunch and learn. So come learn about SRIA's business growth program and how, as a business, you can take advantage to optimize and grow your business. That's going to be next week, Wednesday, October 4th, again from 12 p.m. to 12:45 p.m. And then later in October, we're going to be at BuildX. We've got 2 exciting events taking place in Calgary, of course. And so the lead up to the event on October 17th, join us from the Carbon Leadership Forum from 5 to 8 p.m. for a sustainability social and warm up of your networking skills ahead of BuildX. And then on October 18th, 3:30 p.m., join us for SRIA's Smart Sustainable Tech Showcase, where 5 companies will showcase their innovation to reduce carbon in buildings. Okay, so jumping now into the project. We've been hearing a lot about and seeing more solar panels on homes, electric vehicles parked in driveways these days. This has brought some interesting challenges and opportunities for the electrical distribution system, which our project partner ENMAX is embracing. This project has ENMAX collaborating with residential customers to install batteries in homes where distribution equipment is constrained due to low growth from EV and rooftop solar adoptions. So I want to welcome our speaker today, Najma Sultanat, who's a senior engineer of grid innovation from ENMAX Power, a subsidiary of ENMAX, who's going to tell us all about the project. And just of note, because we have more people than perhaps we normally would have, and we're going to try and hold it to the 1 hour and finish by 1 p.m., please put questions in the chat during the presentation, and then we're going to try and leave time at the end for Najma to answer those questions, and any that don't get answered, we'll send on to Najma so she can follow up. So with that, over to you, Najma, to present ENMAX's exciting project.
Thank you, Alex. Thank you for your intro. I'm going to share my screen first and then start talking about this exciting project. Good afternoon, everyone. Let me know if you can see my screen, because I cannot see your face anymore when I'm sharing my slide deck.
We can see it.
Awesome. So I'm going to start with a quote by Arnold Schwarzenegger. The future is green energy, sustainability, renewable energy. To be an active part of this energy transition to net zero sustainable future, Calgarians are adopting rooftop solar and electric vehicles. And these clean energy means are introducing some new challenges for the utility. I'm here to talk about the residential energy storage pilot project that we kicked off as of March 2021. I would like to start by acknowledging SSRIA for their generous support of our pilot through their Green Building Technology Network funding. As I have shared this link with all of my network through LinkedIn, for the benefit of the doubt that not everyone will be from Calgary or Alberta, I'm going to take this opportunity to introduce ENMAX, ENMAX Corporation. Headquartered in Calgary with operations across Alberta and Maine, ENMAX Corporation is a leading provider of electricity services, products, and solutions. ENMAX Power is the regulated business under ENMAX Corporation. We own, operate, and maintain the transmission and distribution system that serves more than 500,000 customers in and around Calgary. I know that this is not a power systems 101 course, but for the sake of showing the energy transition, what is happening today, I'm going to start from how we used to define the fundamental principles of making electricity widely available for last 100 plus years. The way the fundamental principle used to work for last 100 plus years is we need to create electrical energy at large generating stations. Big generators achieve some economies of scale that help to decrease prices. And then we need to create a continuous path for the electricity to travel where we need it to go to our customers' end. And most importantly, we need to make it uninterrupted. That means reliability. We need to make sure that lights don't go out. Wares must handle maximum need at any point of time. In other words, when demand grows, we need to build more wares and poles. Historically, the entire process was so predictable with smooth transition of load profile to highest demand in the afternoon. But with penetration of more solar and EV chargers in the system, shape of this load profile is shifting. With those adoption of electrical vehicles and rooftop solar, increasing localized generation and consumption presents a unique problem for utilities because they are not coincidental. Instead of rooftop solar microgeneration being used to meet the increased charging from EVs, we see two emerging challenges. Number one, increasing reverse power flow at midday when rooftop solar is generating and pushing excess energy to the grid. And number two is increasing peak load in the evening when EV users add their charging demand to a time of the day where we already observe peak system demand from household dinner time routines. Energy storage has the potential to shift that excess midday renewable generation to later in the day when residential customers need it the most, maximizing both efficiency and GHG reduction potential of these technologies. Adding distribution system visibility and control of batteries is essential as it allows utilities to optimize the battery charge and discharge events to meet real time system demands. This visibility allows NMAX Power to optimize existing distribution assets in coordination with distributed generation from rooftop solar to minimize reliance on Alberta's carbon intensive grid. We are looking at California's net demand profile as the early warning sign. Due to more renewable penetration, California's load curve used to look like a duck in 2018. This is the graph on the left of your screen that it used to look like in 2018. And as recently as in April 2023, Electric Power Research Institute, EPRI, has pointed out that this duck curve is now more closely resembles like a canyon. A good place to start is with the duck curve. This is a 24-hour graph of the net electric load, which allows a unique shape as increasing levels of solar are integrated into the grid. During the day, when renewables are readily available, grid net load dips. This becomes problematic due to the ramp up when the sun sets and demand is high. The increasing penetration of solar and other variable renewables means that the graph dips lower during the day when even going into negative sometimes, and then the ramp up are way steeper than before after sunsets. So instead of a duck, the graph now looks like a canyon. While the canyon curve is a challenge, there are ways to deal with the changing reality on the grid. We need flexibility to be able to react to changes in demand quickly and efficiently without having to rely on fossil fuels. And that starts with energy storage. California is already abandoning net metering as a result of too much solar and are biasing towards residential energy storage to help solve this problem. That was about California. Let's come back to Alberta. What are we are seeing in Alberta? As shown in ISO Alberta Electric Service Operator 2021 long-term outlook, a typical load profile in Alberta in 2021 used to look like this graph on your left of your screen. So you can see it is already forming like a duck. And as projected in the same document, the load profile in Alberta will how it will look like in 2041. It is dipping more, and you can see the duck is already forming here. Let's see what we are seeing at ENMAX. Customers' interest in becoming prosumers is increasing. To meet this customer's need, many developers now offers solar PV panels as standard on new home builds. As we can see in our ENMAX DER statistics, in January 2019, this is the middle graph on your screen. In January 2019, we had 500 microgenerators connected to the system. Today, we have over 3,500 microgenerators. How about the microgen applications? They are continuously increasing exponentially. I'm sorry. Um, I will have to go to the full screen mode again. So as I was saying, the DER application count, it is growing exponentially. It was 500 as of 2021, and it is over 2,500 as of April 2023. Following California as a role model, looking at Alberta ISO's 2021 LTO document, long-term outlook document, and also what we are seeing in our DER statistics, ENMAX Power has adopted a future utility strategy focused on electrification, grid modernization, and customer programs and services. Number one, enabling electrification with flexible loads can improve asset utilization of existing utility infrastructure. Electrification is enabled through EV make ready infrastructure, smart charging programs, EV fleet services, and so on. Number two, grid modernization. Grid modernization will require leveraging new tools and data analytics in response to the operational requirement of a bidirectional grid, resulting from increased adoption of DER or EV. Number three is customer affordability and choice. Utilities like ENMAX Power will need to provide new value added products and services to customers, including non-wire solution that can enable optimization of grid assets and reduce peak demand. Behind the meter energy storage, side management, including demand response, energy efficiency programs, vehicle to grid, virtual power plant are programs that are already being offered in other jurisdictions. The project that I am covering in this presentation today is residential energy storage is part of the modernized bidirectional grid, which is also a new item in the customer's choice list. So what we have done as part of this project, through this pilot project, we have installed behind the meter energy storages in 5 customers' households. We are specifically targeting areas of the distribution system that have transformer overload conditions due to DER adoption and or electric vehicle charging. We will be testing our ability to add distribution system visibility and control to the storage devices. This will allow us to schedule the batteries to unlock useful grid services. One example can be scheduling the batteries to charge in mid-afternoon when the solar generation is highest and discharging in the evening when the demand from households and EV charging peaks. This kind of scheduled approach can optimize grid assets, reduce overloads, and reduce our carbon footprint. This is an exciting pilot project where we are working directly with our customers on exploring a world where customer assets can provide grid services. This will allow us to develop local solutions for local problems and unlock potential customer choices, which provides customers with a better understanding of the impact of new technology on the grid. This leads to increased customer engagement and satisfaction. This is the project timeline. As I mentioned, we kicked off this project in March 2021, and then we finished our installation and commissioning of those 5 energy storages in our customer garage as of November 2022. In between, like mid-May 2023, we started our data tracking of from those battery profiles. Our final report is due by December 2023. So as you can see in the project timeline, we are in the phase of collecting the data from different data sources and analyzing the data accordingly to finish the reporting by December 2023. So potentials. There are some potential that we have considered when we were launching the project. Number one, can we use energy storage as an alternative non-wire solutions to traditional investments? Number two, how can we control and monitor our batteries? And number three is, can we combine several household batteries in aggregate? Our expectation and hope is that with careful control and monitoring, several household batteries in aggregate can optimize our system and provide local grid services. This is a site photo of the battery energy storage that we installed in one of our customers' garage. As you can see in the left side of your screen, we have picked generic power cell as our product for this pilot demonstration from different options in the market. And this is the inverter beside the energy storage. It is a 18 kilowatt hour capacity energy storage. And the picture on your right is the same energy storage without the lid on it. So if you take the cover out, you can see there are 3 battery units, each having 6 kilowatt hour capacity. So 3 units is in total 13 kilowatt hour per household. Three data sources that we are relying on to collect necessary data for successful demonstration of a behind-the-meter energy storages are AMI, Advanced Metering Infrastructure, Energy Platform Management Platform, and Power Quality Meters. AMI will provide us with the load profile of the specific households where we install the batteries. The AMI data will be utilized to identify household demand profiles. By collecting data from AMI with a 15-meter sampling rate, we can gain insights of a dynamic changes in the load profiles and adapt our operating procedures accordingly. Energy management platform allows us to monitor and control the batteries remotely. This is the means to combine multiple batteries in aggregate, and also how the two-way energy flow is impacting the grid to optimize grid assets and avoid any overload conditions. The third one, power quality meters, will provide us with the load profile of the secondary side of the distribution transformer. These meters are capable to provide aggregated load profile at the transformer level. After collecting data from all those sources, we will analyze the data to prove or disprove our preliminary hypothesis for this project. So, what we have learned so far, as the preliminary raw data is showing us, batteries can be discharged during power outages to ensure customers have an interim measure to avoid power loss. Our system operations team has already confirmed some duration when there was some unplanned outages on our grid, but our customers could avoid power loss on their critical load panel. Number two, excess solar generation. As we expected, starting from this project, excess solar generation can be stored and used during the time of peak demand to prevent system overload and reverse power flow. Number three is the interesting one, that aggregating multiple batteries to discharge at peak demand allows for increased capacity on the system and overall lower infrastructure upgrades due to capacity constraints. Avoiding costly upgrades to meet increasing demand will eventually avoid increase in energy bill in future. Behind the meter energy storage has great potential for optimizing our grid assets and increasing satisfaction with customers' symbiotic relationship. So this is one battery profile, like how the battery is charging and discharging in a 7-day period. I just got one clip of that battery profile, charging and discharging profile from our energy management platform. As I mentioned that, when we schedule the charging and discharging was the starting of the year. So as you can see, like say in Calgary, we were looking at the daytime and we were scheduling to charge during 9 a.m. or 10 a.m. in the morning and discharging during 5 or 4 p.m. in the afternoon. So as I mentioned in my previous slide, aggregating the batteries. So in energy management platform, what we did, our 5 energy storages in 5 households, we aggregated them in 2 platoons. In one platoon, we have 3 energy storage, and in platoon 2, we have 2. So we can aggregate them, we can charge and discharge them as a platoon to the grid to have the grid services or increase the grid capacity. This is our expectation. How this charging and discharging profile of the battery is impacting the house net demand and also the grid capacity will be available in the final report. So stay tuned. Barriers identified so far. This is the interesting slide for me because most of the time we think that technology is about understanding whether the technology will help us or not. But in real world, it's all about like whether our codes, standards, regulations, and having all the tradespersons ready for this kind of technology installation. So let me start with my very first one, qualified tradesperson. Lack of this qualified tradesperson is one of the significant challenge for behind the meter energy storage installation. This challenge hampers the timely and efficient deployment of this new technology. It is crucial to work with qualified professionals who understand the relevant codes and standards and can ensure compliance. Thoughts for partnering with experienced consultants or energy management providers can be considered to overcome this expertise gap, at least for near term. Number two, course and standards. Course and standards can be a guide for us, they cannot lead us. Energy storage involves electrical and fire safety considerations that require adherence to specific building codes and regulations. We are working with our AHJ authority having jurisdiction, who is City of Calgary inspectors and safety specialists, and Calgary Fire Department to interpret the NFPA requirement, the CEC code, and to align with the building codes. As the code is vague, to understand the safe or need of a mechanical barrier in a garage in front of the energy storage to avoid any vehicular incident, we are using the example of California to meet this requirement. We may ask for a code change in the next update as we learn from this pilot demonstration. At any cost, we need to consider every aspect for proper installation and maintenance to ensure safe operation of the battery system. Number three, policy. Collaboration between utilities and regulatory bodies will be critical to establish well-defined guidelines for this kind of technology. With more of these technologies being deployed, it is necessary to build capability and capacity within trade allies. Last but not least, incentives. Despite the potential cost savings and environmental benefits, upfront costs can still be a barrier for this kind of installation. Financial incentives such as tax credits or grants will always be the driver for this kind of investments to encourage adoption and offset initial investments. As you can see, this pilot project was possible just because of SSRIA's funding. In the as I mentioned in the project timeline, we are in the data analysis phase. We are capturing all the data from different data sources to calculate greenhouse gas emission reduction, energy savings, and um, grid hosting capacity. You will find them in the final report as they will be available as of end of 2023. Now, I want to help you to see the future. We started this project with some hypothesis, where we are at right now and what is future is holding for us. We had some questions when we launched this project. Can we use energy storage as an alternative non-wire solution to traditional investments? And the answer is yes. ENMAX can utilize energy storage systems as an alternative to traditional investments. Second question we had in our hypothesis was how we can control and monitor batteries. The answer is we can control and monitor batteries via an energy management platform. This will enable an advanced system planning without changing the customer experience. Third question we had in our mind was, can we combine several household batteries in aggregate? And we have already demonstrated that with careful control and monitoring, ENMAX can combine which in future can be an opportunity for ENMAX Power to launch VPP, virtual power plant, if needed during emergency situations. And most importantly, residential energy storage is a critical component of an energy efficient net zero home. And in addition, This customer's asset can also provide local grid services. Now what? Our focus of this residential energy storage was to understand and meet our customers' need while solving the grid problems using our expertise. We are here to empower our customers so they can make informed decisions in how and when they use electricity. The deployment of this technology, like energy storage, can also mitigate the increases of the total cost of energy while maintaining a reliable and resilient grid. Please take some time to read the final report and check the data of this residential energy storage project when they are public in Surya website by end of 2023. Feel free to reach out to me to share some thoughts on similar kind of clean energy initiatives. As a final note, we are on the verge of a transformation of the energy sector, and ENMAX is paving the way for Calgary to embrace that change. Let's all join this journey. Thank you.